discuss about some of the concepts in stochastic processes. So the basic terms we have already discussed in stochastic processes 1. So I'm going to discuss furthermore about the absorbing states or the absorbing Markov chains in stochastic processes. Right? So if you can remember, when we discuss about the transition diagrams and when we discuss about the states of the transition diagrams, we discuss recurrent states, we have the transient states, and we have the absorbing states, right? So anyway, if you have a transition diagram with n number of states, and if you can find a state where when you enter to that state it is impossible to leave, we call that state as an absorbing state. Right? So if you have a transition diagram or if you have a Markov chain, in order to call your Markov chain as an absorbing Markov chain, you should have an absorbing state in your Markov chain, right? So one thing you have to make sure is how to identify the absorbing state is you have to check whether once you enter to a particular state, is it impossible to leave or not. If it is impossible to leave, you can mark it as an absorbing state. Right? So if you look at this transition diagram, you can see you have 3 states where I have named it as A, B and C, and you can see the probabilities, right? Like when the probability of going from state A to A is 0.5 and from state A to B is 0 likewise. So if you look at state B, you can see if you are in state B, you can't go to state A again because the probability of going from state B to A is 0. If you look at the second row, right? And also if you look at the probability of going from state B to C, that is again 0, right? And if you look at the probability of going from state B to B, that is 1. So that is, if you are in state B, you cannot reach other states, but you have the probability as equal to 1 to be in that state. So that is, according to this transition diagram or according to this Markov chain, you can define state B as an absorbing state. Right? So once you enter to state B, you cannot leave because since the probability of moving from state B to A or C is 0. But moving from state B to state B is equal to 1. So it's an absorbing state. So if you want to call your Markov chain as an absorbing chain, you have to satisfy these conditions, right? So one condition is there should be at least one absorbing state in your transition diagram. So once you draw your transition diagram, you have to quickly check whether you have at least one absorbing state. So now you know what is an absorbing state, right? So even if you look at the transition metrics also, you can identify whether you have an absorbing state or not. So the other thing is, if you have a Markov chain which is an absorbing chain, so it is possible to go from each and every non-absorbing states to at least one absorbing state in a finite number of steps. So if you look at this one again, so B is the absorbing state, A and C are the non-absorbing states. So if you want to call this one as a Markov chain, absorbing Markov chain, you should be able to reach state B, that is the absorbing state, by finite number of steps, right? From state A or C, since these two are the non-absorbing states. So if you look at state A, so if you look at state A, you can see from state A you cannot reach state B, because if you look at the first row, you can see the probability of reaching state B from state A is equal to 0, right? But if you look at the third row, uh, the probability of reaching state B from state C is equal to 0.5. That is, from finite number of steps, you can reach this absorbing state from this non-absorbing state C. So that is, you can call this as an absorbing Markov chain, right? So what you have to check is, first thing, you need to have at least one absorbing state, and from the non-absorbing states, by finite number of steps, you should be able to reach at least one absorbing state. Then only you can call your Markov chain as an absorbing Markov chain. So the next thing is, the important thing is, now if you can find a transition diagram, a transition matrix for your Markov chain with one or more absorbing states, right? Then you can talk about the limiting distribution. If you can remember, we discussed about the limiting distribution in our previous lecture series, that is in stochastic 1. So if your Markov chain is an absorbing Markov chain, it will eventually reach to a limiting distribution, right? So now our task is how to find out that limiting distribution, right? So we will just look at this transition diagram and illustrate all these things using this transition diagram. So you can see, as I told you, you have three states here, state A, state B, and state C. And if you look at the first row, the probabilities are 0.5, 0, and 0.5. That is, the probability of reaching state A from state A is 0.5, reaching state B from state A is 0, reaching state C from state A is 0.5. And if you look at the second row, reaching state A from state B is 0, reaching state B from state B is 1, reaching state C from state B is 0, likewise. So you can see, you can identify that since the probability of reaching state B from state B is 1, it's an absorbing state. And you can see, you can reach state B from state C, where state C is a non-absorbing state. So you can find these two characteristics. So we can call this as an absorbing Markov chain. So if you just draw the transition diagram, right, you have state A, state B, state C, and you can just mark the given probabilities, right? So you can see, once you reach state B, you cannot leave it, right? You can reach state B from state C, but you cannot leave it. You have no way to leave state B. So that's why we call it as an absorbing state. So by looking at the transition diagram, transition matrix, you can quickly sketch your transition diagram, and then you will clearly see why we call state B as an absorbing state. Okay, right. Now, the next thing is, if you have a transition diagram, if you have a transition matrix, right, then if you have absorbing states and if you have non-absorbing states in your transition matrix, we can write down our transition matrix in a standard form. So why we are writing this matrix in a standard form is then it will be easy to find the limiting distributions. Alright, so if your Markov chain is an absorbing Markov chain, in order to find the limiting distributions, we are going to write down the transition matrix in the standard form. So for that, what you have to do is, first you have to identify the absorbing states, and then first you have to write down the probabilities of the absorbing states first in your transition diagram. Right now, for an example, if you look at this one, this matrix, this transition matrix, you can see you have three states, right? And if you look at state A and B, you can see the probability of reaching state A from state A is 1. The probability of reaching state B from state B is 1. So that is A and B are absorbing states. Therefore, what you have to do is, first in your transition matrix, you have to write down the respective probabilities of state A and B, right? So here you have to first state A, B, and then only C. Now let's say your absorbing states are A and C, then you can first write A and then C, then at the end you have to write B, right? Then the order would be A, C, B, right? But in this case, since A and B are the absorbing states, so you have to first write A and B and then C. So when you write the probabilities in this order, you can see, if you just look at the probabilities which are related to the absorbing states, that is state A and B in this case, you can see those probabilities, they are forming a identity matrix, right? 1, 0, 0, 1. And if you just look at the rest of the part of this, this is the identity matrix. The rest of the part, if you look, you have only zeros. So that is known as the zero matrix, right? So likewise, when you write down your matrix as if you write down the probabilities of the absorbing states first, right? And then the non-absorbing states, then you call it as in the standard format. So in the standard format, you can categorize your matrix into 4 parts as I, O, R, and Q, where I is the identity matrix and O is the zero matrix, right? So we will discuss what is R and Q later. So what you should be able to do is, you should be able to write down any given matrix. If it's an absorbing Markov chain, you can write down it as in this standard format, right? Okay, so then when you write it in this standard format, it would be very easy to find the limiting distribution. So let's find the limiting distributions, and let's write down the standard format with the use of this example. So it says two competing real estate companies are trying to buy all the farms in a particular area for future housing development. Each year 10% of the farmers sell to company A, each year 40% sell to company B, and the remainder continue farming. Neither company ever sells any of the farms they purchase, right? So the first task is, you have to draw a transition diagram for this Markov process, and then you have to determine whether the associated Markov chain is absorbing or not. If it is absorbing, you have to write a transition matrix in the standard form. And then if neither company owns any farms at the beginning of this competitive buying process, you have to estimate the percentage of farms that each company will purchase in the long run. Right? So that is what you have to do. So first, what will happen here now? It's like the two companies are like two states, right? There is a big land where you have farms, uh, uh, and in these farmers they sell 10% to company A, right? So at the beginning they all are in one state, but then 10% goes to state A and another 40% goes to state B, right? And the remainder they continue farming, right? So you have company A, company B, and you have a remainder as well. So you can take it as another state. So altogether you have 3 states. So the first task is you have to draw the transition diagram. Can you give a try to draw the transition diagram? Just pause and draw the transition diagram. I'll give you 2-3 minutes. Just identify the states and draw the transition diagram. You have 3 states, and at the beginning all the farms are in one state, and then they will go to, some of them will go to state A, that is for company A, and some of them will go to company B. So it says 10% of farmers sell to A and 40% of farmers sell to B. So altogether 50% of farmers they have sold. So the remainder is another 50%. So the remainder is there. Right. So I hope you could draw the transition diagram. So it looks like this, no? So C is like the original state, right? So the C is like the state where you have all the farms together, and from that there is a 10% who are coming to state A and another 40% who are coming to state B. So those two probabilities are 0.1 and 0.4. So since the summation of those two probabilities are 0.5, the remainder is 0.5. They are remaining in the original state. So from state C to C is 0.5. And also they says once these companies uh, bought these farms, they will not sell them to anyone. So that is, if you belong to company A, you forever belong to company A. They are not selling that again. So that is, reaching state A from state A is 1. You can't go. That's an absorbing state. Same thing with state B. Once you belongs to company B, you cannot leave that company. So that is, you cannot leave that state. So it's an absorbing state. So you have to mark the probability of reaching state B from B as 1. So you can see when you look at the transition diagram, state A and state B, they are absorbing state. And state C is a non-absorbing state, and you can clearly see from state C we can reach to the two absorbing states A and B, right? So we can see the two characteristics. We can see absorbing states here, and from the non-absorbing states we can reach the absorbing state. So we can call this as an absorbing Markov chain. So that is, we can find a limiting distribution. So then the next task would be, we have to find the limiting distribution, right? Okay, so we can find out the transition matrix. So since A and B are the absorbing states, you can write down the transition matrix in the standard form. So first you have to write the probabilities of the absorbing state. So in this case, A and B are absorbing states. So you have to mention A and B first and then C. Right? So if you look at here, A and B first and then C. So if you look at A, the probability of reaching state A from A is 1, right? A from A is 1. Then from A you cannot reach C or B. So those probabilities are 0. And if you look at B, from B to B is 1. From B you cannot reach A and C. So that is, these two are 0. From B to B is 1. But if you look at C, C to A is 0.1, C to B is 0.4, C to C is 0.5. So you can write down these probabilities, and you have to anyway write A and B first, since they are the absorbing states, since we are writing the standard form. So this is the transition matrix which you have written in the standard form. Right? Okay. And then it says at the beginning, these two companies, they had 0 number of lands at the beginning. So if you take the 3 states at the beginning, state A had 0 land, state B had 0, but state C, it had all the lands, right? So if you just look at the initial stage, the probabilities are like 0, 0 and 1, right? And then if you look at the transition diagram, we know what happened. 10% goes to 10% of them goes to state A, and 40% of them goes to state B, and the remainder is remaining in state C. So we want to see the limiting distribution of this, that is at the end, what percentage of the land belongs to state A or company, in other words company A. What percentage of the land belongs to company B? So that is, after a long time, what percentage would be belong to the companies, we need to find that. So that is the limiting distribution. So we know if you want to find S1, right, that is one step ahead. So we have the initial probabilities and the transition matrix. So we discussed this in stochastic 1 as well. So you have to take the initial matrix and multiply that with the probability, that is S1 is equal to S0P. Right? And if you take S2, that is S2 is equal to S1 times P, but we know S1 is S0P, that is S2 is S0 into P square. Right? So that is, if you just take S10, that is 10 times ahead, so we can write it as S0 into P to power 10. So we know S0 is this matrix, and we have the transition matrix P. So P to power 10 you can calculate. And when you see the product of these two, we will get these two values. Right? So that is 0.1998, 0.7992. So that is approximately 0.2 and 0.8. So this is the 10th power. So after 10 steps, 20% of the lands belongs to company A, 80% of the land belongs to company B, right? So that would be the limiting distribution, but here actually we have considered only 10 steps. So we need to find out whether these two figures are actually true. So for that, since we have this standard form, it's easy to calculate this limiting distribution or the limiting matrices. What you have to do is, now since we have written down our matrix using the standard form, you can see, if you look at the probabilities which only belong to these absorbing states, they consist the identity matrix. So that is 1 0 0 1. This is the identity matrix, and then you have this column, that is the zero matrix. You have two zeros, and this is the R. So you have the probabilities of reaching the absorbing states from the non-absorbing states, that is 0.1 and 0.4, and this is the probabilities of reaching non-absorbing states. So that is 0.5 here, right? So in this case, so we have R and Q. Okay, so if you want to find the limiting distributions, the limiting distribution we can denote by P bar. That is, if you take the limiting distribution as Pk, we want to find out P bar, that is the limiting distribution, as k goes to infinity, right? So P bar is equal to this matrix, that is, here you have again the identity matrix, same thing, which comes from here, and here you have the zero matrix, same as this, and here instead of Q you can replace that again with the zero matrix, but R you have to replace by FR. So what is FR? FR is equal to the multiplication of the matrix F and R. R is coming from the standard form. So what is F? F is I minus Q, and then you have to take the inverse of that. Okay, so if you just identify these terms in your standard format, and then if you put it to this P bar matrix, that will give you the limiting distribution, right? So we'll see that with this example. Okay, so this was our initial standard form matrix, and then in this case I is 1 0 0 1. This is the zero matrix, you have two zeros, and now our task is to calculate F matrix. So you can see when you calculate F, that is I minus Q, and then you have to take the inverse of that. So when you take I minus Q, Q is coming from the standard form. So when I is the identity matrix, but in this case when you take the identity matrix, it should be the same size as matrix Q, right? So this I is not coming from the standard form, right? So if you look at this example, now in this case Q is 0.5, that is 1 into 1 matrix, right? You have only one element. So when you take identity matrix, you cannot take this one. This is the 2 into 2 identity matrix. You cannot take that. You have to consider the same size as Q. So you have to consider only 1 as the identity matrix. So you have 1 minus Q is 0.5. 1 minus 0.5 is 0.5. Then you have to take the inverse of that. So that is, in this case it's easy, it's 2. So what you have to do? You have to calculate FR. So you have to multiply this matrix F by matrix R. So matrix F, in this case it's a constant. You have 2. Matrix R is this. You have 0.1 and 0.4. That is FR mean you have to multiply 2 by this. So you have 0.2, 0.8. Right? So now we can write down the limiting distribution, right? So you can see first you have I 0 as in the standard format. Only thing you have to do is R you have to replace by FR, Q you have to replace by 0, right? So R replaced by FR. Now FR is 0.2 and 0.8, Q by 0. So instead of writing 0.5, you have to write 0 here. So you can see the last row. that is the matrix FR gives you the limit in distributions, right? So that is after a long time, company A will own 20% of the land and company B will own 80% of the land. So actually that is the same thing, which was very close, 0.1998, it was very close to point 0.2. Same result we got by manually calculation. So this way it would be very easy to find out the limit in distributions, right? You can apply for any absorbing Markov chain. So if you can find out the properties of an absorbing Markov chain, in that case, if you want to find out the limit in distribution, you can apply this fundamental, you can find out the standard form, and then you can apply this method to find the limit in distribution. So in this case, for the matrix F, we call it as the fundamental matrix, right? We call it as the fundamental matrix of the transition matrix, right? So how we calculate is we have to take the difference between I and Q, where I is the same size as Q, and take the inverse. So using this fundamental matrix and using the standard form of your transition matrix, you can easily calculate the limiting distribution of an absorbing Markov chain. So I hope that is clear for you what is an absorbing state and how to find a given Markov chain as an absorbing state, and how to how to write the transition matrix in the standard form. What you have to do is, after identifying the absorbing state, you have to just take the probabilities of the absorbing states first in your transition diagram, transition matrix, and that would be known, and that you can call as the standard form of the transition matrix. So in the when you write down your transition matrix in the standard form, you can categorize it into four matrices. That is, you will see an identity matrix, you will see a zero matrix, and you have R and Q. And using these, you can calculate the fundamental matrix, and using that, at the end, you can find out the limiting distribution, so the limiting probabilities, right? So I think that is clear with you. So you can just go through the examples and see, and also you can just check the examples that we have discussed in stochastic 1, where we found the limiting distributions. If you can identify those Markov chains as absorbing ones, you can just apply this method and see whether you get the same answer, right? So I think we'll stop from this point then. Thank you.